Hello everyone, welcome to Module 5 how-to video. And before we get too far into this, let me just go ahead and show you what we're supposed to do. As you recall, in Module 5, this is the SOS blink pattern. Let's see, I may have toggled it to, I toggled it to OK. So let's go ahead and demo that. So if I hit this toggle button, it's going to show you a yellow button immediately that lets you know that a toggle is coming, that you've pressed the button. And then as soon as the pattern, the SOS or the OK pattern that's currently executing finishes, it's going to toggle the state. And so we were in the OK state, now we're in SOS. So let's see how that goes. We got 3 dots. Yeah, 3 dots, that was the end. 3 dashes. Notice they're longer. 3 dots, that's it. 3 dots, 3 dashes, 3 dots. 3 dots, 3 dashes, 3 dots. And then we pause for the prescribed time. And they gave you some specific numbers in there for the durations of both the LEDs and the spaces between. So now I'm going to toggle it. See the yellow? The yellow will go away as soon as it toggles. Okay, now we're in the OK pattern. So you got 3 dashes, a dot, a dash, and a dot. Just repeat it over and over. 3 dashes, a dot, a dash, and a dot. And remember, the dots go on the red LED, the dashes go on the green LED. So that's it. It looks simple. Let's take a look at the code. Well, first let's take a look at the requirement. Now this is the milestone 3 timer interrupt lab guide. So we're going to a lot of this is just how to get started. You know, pick your workspace, find the project that we need, and that's going to be down here. Here it is. It's the GPIO interrupt. Now notice it's under CCS compiler here. We're not going to have that unless you've got a very old SDK, like version 4 or something. I believe I'm working with version 7 something right now. And so what I use is the TI Lang compiler, and that's what you're supposed to use in the absence of the CCS compiler. So just remember that. And I went through all of that in the last video. So if you don't remember it, just go take a quick look at the first few minutes of that. And then your board. Now this is a little different. Select a target. I'm pretty sure that well, let's just take a look. Let's take a look. This is Code Composer. So let's see if I can find the Resource Explorer. So we want to go to wireless, I believe. And we want to go to embedded software, maybe. Now, here you see the one with the green check mark here. That's the SDK we have installed, 7.10.00. So let's look under there. Since that's the one you have installed, you want to get everything out of there. Then we're going to go to examples. Now, this is what I was talking about in the old version, the old SDK. You picked everything first, and then it would ask you to select your target, like CC-350S or SF. I have an S. If you have an SF, then you would go a different route and go down in here. But once you get in one or the other of these, I believe it all looks the same. So let's go here, and we're going to go to TI drivers, I believe, and GPIO interrupt. And I believe it is no RTOS. And we don't have the CCS compiler, so we're going to pick the TI lang compiler. And then you see here's the GPIO interrupt project. So just click the three dots here and load it into your IDE. I think you've done that several times already. So, but that's the way to navigate to the project you're going to need this week. So put this away for now. Go back to the requirements. And you're going to need to go into the sysconfig file here and add a timer. And it says to make it a 32-bit timer. So be sure to do that. And it's going to be timer 0. So if you haven't, I'm glossing over this, but if you have any issues, get in touch. And then they give you some starter code. It's such as it is. It's a little bit of code here. Of course, in addition to the code that's already in GPIO interrupt. There's a lot of infrastructure in there, but then you'll want to go ahead and put this in. Now let me give you a good suggestion right up front. You're going to need this timer handle defined at the class level. So when you take this code and put it in, you can leave a lot of it as is, but I think they want you to change this period. But we're going to be changing the period every time we start the timer anyway, depending on whether it's a dot, a dash, or a space between. And that's why you're going to need this handle out in some of your other methods. And so you're going to want to take this and move it. Don't do what I did initially and copy it up. And I knew better, but I just didn't go back and remove this one. But go ahead and move it up to the class level, up top with all your other defines and such. And what's going to happen if you do that, if you copy it up there and then don't delete this one, Then what's going to happen is in init timer, uh, it's going to initialize. This is gonna be a different local timer handle, and so after you init timer one time, then every time you use the class level timer handle, even though it has the same name, it's not the same handle, and so it is going to have no effect on the period of your timer. And I kept noticing, oh, okay, the lights are turning on and off in the correct order, and I can toggle and everything, and it does the OK versus the SOS, but those durations look suspiciously all the same, and I would manipulate my numbers, the period numbers for dash and dot and in between, and it all still looked the same. And finally, um, I dug in and I found that I had this extra local timer handle inside init timer, um, and it was causing my class level timer handle not to have any effect because it was pointing to nothing. So don't forget that. I would do that immediately. Save yourself a lot of agonizing. Okay, after doing all of that, think about what's the purpose of the timer callback function. Okay, the only thing I'm doing in the timer callback function is setting a flag to true that the timer is finished. It's just called timer flag. You could probably call it anything. Um, so it's just a place to set a class level variable, um, that it's going to have a value of 1 or 0. So while the timer is executing, uh, that value is going to be 0. And then as soon as it's not 0, then to go ahead and turn your LED off. What does period mean in this context? Okay, that's the length of time that it's going to take for the timer to return and set that flag to 1. And it's in, I believe it's in microseconds. I think you need to pass in microseconds, and then because I believe in the timer it's going to divide whatever you pass in by 1,000. So if you pass in 500, which I believe is what it says to do in these instructions, it's going to be a very brief interval, duration, a very brief flash. And so whatever they tell you, I would multiply that by 1,000 and pass that in. So, if they tell you 500, you want to pass in 500,000, that sort of thing. And what does the period mean? How does the timer continuous callback parameter impact the driver? Well, I think it's as opposed to periodic. And what is GPIO button FXN0 used for? Okay, we're going to use that as a callback for one of the 2 buttons. Now, if your board is like mine, and I suspect we all have boards with 2 buttons, and remember, I'm using these buttons as you're directed to do to toggle the state. So remember, you see I can press this button and get a toggle. See, the yellow light came on indicating that the button was pressed. And then as soon as it actually toggles, the yellow light goes away. And now I'm going to press the other button, and it does the same thing. So that's what the GPIO button 0 FXN is used for. And then you'll need to probably make another one, GPIO button 1 FXN. Doesn't have to be called that, but since that's what they called it, I stuck with it. What is the purpose of GPIO config in int falling? Okay, I believe that is when the button, immediately when the button goes from high to low, as soon as you release the button, it's going to execute, it's going to go to the callback. Okay, now is the time to modify GPIO interrupt C in the code provided in step 13, which is up here. Okay, call your state machine every that many microseconds. And so we're just going to change this number to that. And continuously blink SOS and Morse code on the green and red LEDs. Okay, that's what we're doing, unless we toggle. Okay, but I've already shown you this. That's the initial state. It continuously blinks SOS and Morse code on the green and red LEDs. Green are the green button. The green LEDs are for the dashes, so they're going to be a little more a longer duration, and the red LEDs are for the dots, shorter duration. If a button is pushed, toggle the message between SOS and OK. Okay, I've demonstrated that. We can do that. Pushing the button in the middle of a message should not change the message until it is complete. Okay, I've demonstrated that as well. Remember, as soon as you push the button and it goes to the callback, it's going to turn on a yellow light in between the red and green LEDs. There's nothing says you can't do that. And I just did that for my own sanity to make sure the button callback was working, and then I just left it in. And it's a good signal to somebody that, okay, the state is about to change. As soon as this sequence of blinks that we're currently executing is over, then the pattern's going to change. And when that happens, the yellow light goes off. Okay, if you wish to perform your own research on how Morse code works, okay, the following guidance will help provide a base for the functionality you're creating. Okay, and the key word here is guidance. I stuck pretty close to these, but sometimes, and remember, this is in microseconds. I'm sorry, these numbers are milliseconds. So you've got to multiply these by 1,000 to have the same impact that they're hoping you'll have with these numbers. Because in the timer, you see this is microseconds. So be sure to do that. And then, once you do this, and if you think, wow, that sure is taking a long time, you can shave off the last zero on some or all of them, and just make it look more to your liking. Now, the uh, one thing I noted for myself in the assignment, especially with regard to the state machine diagram you're going to make, it's more important that what you do matches your state machine diagram. That it's more important that you get that all synced than to have it working perfectly according to the specification. So, don't worry too much about if something's not quite right. But one thing I want to mention with regard to these durations for the dots and the dashes and such, you have to be pretty careful if you make some of them too small, especially the word space and the character space. You're going to see some very strange looking behavior. It's going to look like they're on all the time, but if you look closely, you can see an almost imperceptible blink, but it looks nothing like the pattern we're expecting. So if you see that, don't panic. Just fix your durations back. And of course, you'll have those in constants. Hopefully nobody at this stage is just hard coding in numbers for every call to timer set period. You want to have those in constants, like dot duration, dash duration, character gap, word gap. I think those are the four you're going to need. Have those defined up top, and then if you need to tweak them, you just go to that one place. And it's a nightmare, maintenance nightmare if you just hard code in the numbers. I'm sure you all know that. And then just some stuff here you might want to take a look at. Okay, now with that behind us, let's look at the state machine diagram that I have worked up. I'm sure you can do something more sophisticated than this, but this is just what I came up with this afternoon. So you've got the initial, when the algorithm starts up, the initial state is going to be this SOS state. And then you've got these two buttons here, these two user buttons that I showed you earlier. The user can press one or the other of these buttons. I would imagine you could press them both at the same time. I didn't do that, but the way I have it coded up, when I check every time the current sequence finishes, like if we're running an SOS sequence, when that finishes, then before I call the routine again, and we'll see that in a minute. Before I call that again, I check the state of the button presses for both buttons. If it's a 1, it's going to be 0 starting out in life. And in the callbacks, just like with your timer callback, you're going to need to set that volatile variable equal to 1. And I have one, of course, for each button. So I have a button 0 state, a button 1 state, or and so then I check if either one of those is a 1, then I know that the a request for a state toggle has come in. And so the first thing I do is turn off the yellow LED, as we know it's on. If one of those buttons is high, the yellow LED is on. And then because that happens. That's the other thing that happens in the callback for the button. But I did that myself. There's nothing in the instructions that says to do that. But if you choose to do that, be sure and turn it off as soon as you check inside your infinite loop. You'll check every time through and see if that's one of those buttons has been pressed, and if it has, and you've turned on the yellow LED, turn it off, and go ahead and one thing, another good best practice too is I tried to encapsulate a lot of stuff into um, atomic um, functions. For example, if I want to change the state, I don't write the same code in multiple places to do that. I have a toggle state method, which you'll see in a minute. And then, if I find one of those buttons is high, I turn off the LED, call toggle state, and then I set both buttons values equal to 0. It doesn't matter which one was pressed. We got the request. We're going to toggle it, and that takes care of it. So go ahead and toggle the state, and then call your routine again that reads. There's a class level variable that tells it whether the state is SOS or OK, and and call the method that reads that state and then executes a pattern accordingly, either the SOS pattern or the OK pattern, and then returns there, and then we check the buttons again and all over. So anyway, it's not too bad to do. So let's be sure and do your state diagram, and then of course you can let's see, how do we do that? Save this to export as, I think it said PDF. And go ahead and export that. Okay, so now let's take a quick look at the code. Now I'm going to give you in the announcement, I'll give you some starter code. I'll probably just paste it right into the Welcome Module 5 announcement, and you'll need to just copy it out of there and put it in. I wouldn't just copy the whole thing and overwrite all of this. I would cut out pieces and put it in. So remember, I think it was in the last announcement for Module 4, the one I mislabeled initially as Module 5 because I was coming down with this cold that I'm still suffering from at the time, and I had been knee-deep in Module 5 readings while I was making the announcement. So, but because of that, I think I showed you a pinout of the board. So these user LEDs here and these buttons, one here, one here. They have specific pins, and so the red user LED is pin 9, yellow is pin 10, and green is 11. Now that's on my board. That's the uh, CC-3220S. Now, if you have the SF, it could be different. So if this causes odd behavior, I would go and look at the pinout for the SF. I would, it could be the same, but I just don't know. Now this display, I'm pretty sure I abandoned that. I thought I had gotten rid of it. Let's see, what else do we have? Okay, we've got our standard includes, and of course you're going to need the GPIO, the timer, that sort of thing. And then I made an enum of states so that it's just easier than remembering, okay, state SOS is at a 1 or a 0 or something else. So you see, you can just check it like this, and it's a 0 because it's the first one in the enum. And here are our duration constants. So you're welcome to use all of these the same or not. But just remember what I said, to be careful with the with those durations, because it can cause it to look like it's malfunctioning, and in reality it's executing your sequence. It's just not obvious to the eye. And then button pressed. Now I don't think I'm using this because I have, let's take a look. I'm sorry, I should have cleaned up. I thought I cleaned up all my dead code before this. Okay. But that's a good idea, as you know, you sort of have to be constantly looking for stuff like that. So everything I've commented out, I'll come back in after. And the way I do it is after the next build, and I see it's working fine without that, even though I couldn't find another instance of button pressed. Just to be safe, I give myself a little buffer, and so I do another build, and I load it and I run it, and I make sure everything's still working with the stuff commented out. Then the next iteration, I go back and actually delete it. Pattern index. Now here's some more dead code. Let's see. Yeah, and the reason I'm pointing this out is I don't want you guys writing all this down and then as you're working, trying to figure out what to do with it, it's useless. Processing message. I think that's dead. Yep. Timing state. That's dead. As you can see, every iteration I simplified, and that's the way, you know. Just I tend to start out brute force and you know, improve, be more sophisticated as I go. But okay. Now, of course, the timer handle. Remember what I told you about that. You're definitely going to need that. So let me make a little space between that and the dead stuff. Toggle message. Now these are um, function declarations, and as I'm sure you know, um, unlike some of the other languages and environments, if you call something that's defined downstream from where, in other words, if I had the whole function toggle message body up here above um, the first time I call it, then I wouldn't need this extra declaration. But as soon as you, just so that you can put things in a more logical order below, you may want to put them in alphabetical order. You may have some other way of doing it. Personally, I have no pattern for that. It's just whatever makes sense to me at the time. But I have been involved in projects where people liked you to put things in alphabetical order. To me, that just doesn't seem to have any value. Well, I guess suppose you could find it quicker. But typically nowadays, especially if you're working in Visual Studio, C#, that sort of thing, you just right click on it and go to definition or go to implementation. You'll find it. So that becomes less necessary. So here's our blink Morse. I may not have actually needed this one, but blink dot, blink dash. I need those because inside blink Morse, we're going to call blink dot, blink dash. And this is back to what I was talking about with regard to encapsulating atomic things in atomic methods. In atomicity, I believe it just means it does one thing only, and it's not dependent on anything else. So, blink dot, where is it? It's down here, and it's going to set the red LED to high, and then it's going to set the timer period to dot duration. And remember, dot duration is up here. And so that's what I meant earlier about you don't want to have hard-coded numbers in these calls. Like you don't want to put the 50,000 or whatever it is, 500,000 number in here. Those are called magic numbers. People come back later trying to maintain your code and have no idea what that number represents. But if it's in a constant, a well-named constant, then it's a lot easier to maintain. You know what it is, plus if you want to change it, you don't have to worry about how many places it's being used. And also, if you're using magic numbers, you could get out of sync. You might intend to pass in 500,000 for dot duration everywhere, but and especially after multiple people come in and working on the same code, somebody else changed it, but only in the place he was working, he or she, and so you could get some strange behavior. So best to keep it in constants. That way, if the other developer decides they want to change it, they can change it everywhere with no problem. So blink dot, blink dash. So now more encapsulation here. So inside set timer period, which is, I believe, and here's the timer callback, just sets a flag. Set timer period. So I'm stopping the timer. I'm turning the timer flag to 0. remember when the timer finishes execution and comes back here, it's going to set that flag to 1. So it would remain 1 until you changed it. So set that to 1. Call timer set period, and using your handle, timer 0, and then the timer period, and the duration that we passed in. And remember, we passed in dot duration in this case, but you can pass in any of those constants as the duration. And by the way, that's why I did have those as pound defines up here, just like these, but I changed them to constant integers because it just seemed a lot less likely not to work. If it's definitely expecting an integer value, and if you just have it as a pound define up here, it doesn't have any explicit type, and so I recommend doing this instead of the pound defines for these durations. So anyways, you can see this is a little cleaner than it could be, which is a good thing. So this one line of code is gonna execute 3 dots, 3 blink dots, 3 blink dashes, 3 blink dots. That's our SOS pattern. If the current state is SOS. Else, and there are only 2 states, so if it's not SOS, it's okay. And so we're gonna blink 3 dashes, then a dot, a dash, and a dot. So if you set everything up for yourselves in those little atomic methods that encapsulate all of this kind of thing, then the rest of your logic, you can look at your code then and just see the pure logic. You're not wading through all of these ancillary operations that that piece of logic needs to do. It's just going to call this, and then if that's not working out, then you just go here to this one thing, and it fixes it for every time you need it. So timer callback, set pattern. This is this is toggle message. So when I check that button, it's if one of those buttons has been pressed, we know that we want to toggle the state. I should have called this toggle state, but I didn't. You might want to do that. So if the current state is SOS, we're going to set the state. I called it set pattern. As I said, I simplified as I went along. There was a lot of other junk going on here that made this name seem like a good idea at the time, but no, it isn't. So you set the pattern. If it's SOS, you set it to OK. Otherwise, if it wasn't SOS, that means it was OK, so you set it to SOS. And then all we're doing then is setting this current state variable to one of those enumerated values. Remember the enumeration, I made it here. And enumerations are good for instead of just setting it to 0 or 1, it's almost like a magic number. This way you see exactly what you're doing. Now, these are going to resolve to 0 and 1. but we'll let the machine deal with that. Okay, so init timer, this code is pretty much given to you. Just remember, in the code they provide that timer handle of timer 0 is in here. Go ahead and move that up to the class level. And don't leave it in here or you'll have trouble like I did. Timer init. Yeah, this is all pretty much given to you. I think they want you to change that down from a million to 500,000. Okay, these are the button callbacks I mentioned. I'm setting the flag to 1 for that button. Here I set the flag for this button to 1. And in either case, I am turning on the yellow LED so that, because in a larger system, the person who pressed the button and asked for a toggle of the state, may not just be the only person involved holding a little board like this. It could be somebody you can't see, and but then the user would then see, okay, the state is about to change. So, and I just did it, as I said, to alert myself that the button press was recognized. And then I thought, well, I'll just leave it in. So that's totally up to you. But if you do turn it on, then when you go down here and check these buttons, so remember this is the main thread. So we're going to initialize the system, and I got that up here. And like I said, I'm going to give you some starter code, some fairly robust starter code. Is I don't want you sweating too much this week. So we're going to initialize the system, init the timer. We've already looked at init timer. And then while 1, infinite loop, we're going to check to see if a button has been pressed. If it has, we're going to toggle the message. And I think if you'll look in init system, the first thing we do in a init system, we set the pattern to SOS. So that's, but we haven't executed the pattern yet, because that's done when you call this. So theoretically, and I am sure practically, someone could press the button if you pressed it very quickly before this is ever called, but you'd have to be quick. And so you could sort of hijack it, make it start out in OK mode. I suppose you could call this first, but I'll leave that as an exercise for you. But the way I'm doing it, check both of these flags. If either one of them is high, meaning it's on, it's 1 instead of 0, then I toggle the message. And remember, we looked at that method. It just checks to see what the current state is and changes it to the other one. And then I set both button flags to 0, because I don't know and really don't care which one was 1 at this point, because when we come out of this piece of code here, we're going to have them both equal 0, because that's the only thing we needed it for. We need it to be 1 long enough to toggle the message. And then finally we turn off the yellow LED. And then we call blink Morse. So let's take a look at that. And that's way up top. And we've already looked at that. Blink Morse. It's going to check the current state. If it's SOS, it's going to do this pattern, else, and the only other state is OK, else. So it's going to do the OK pattern if it's not SOS. So that's, gee, I hope you can hear me with this cold. So that's the code, and I've been scrolling, hopefully slow enough for you to pause, and if you're watching this as you code, and you're welcome to do that. You can fill in the to-dos in the starter code. So that's it. I hope everyone has a happy Thanksgiving. I tried to put together a good package for you so that you wouldn't have to work on Thursday and hopefully not even on Friday. But if I were you, I would, if you can, I know you got other classes, other responsibilities, but if you can get everything done, at least by Thursday morning, and have a nice break. But I hope everyone has a nice holiday, nice Thanksgiving, and I'll see you next time.